Hello children, welcome to Lucid Study and Mathematics class. Today we are going to discuss a interesting chapter, that is Geometrical Constructions. I know everybody's favorite chapter is Geometrical Constructions. So let us see some more constructions in this class. Okay, so we are going to discuss about the basic constructions now. That is first one, perpendicular bisector of a line segment and angle bisector of 30 degrees, 45 degrees, 60 degrees, 90 degrees and 120 degrees. That is what we are going to learn. So already we have learned perpendicular bisector how to draw. But why we have to draw like this? Is there any meaning behind it? Justification, everything we are going to learn in this class. Okay. So the first one, to construct the perpendicular bisector of the given line segment. So draw perpendicular bisector of given line segment AB and write justification. Okay, so let us draw this. So first let us take a line segment AB of any length. Okay, line segment AB I will take. So I will name it as a AB line segment of any length you take. So now we need to construct the perpendicular bisector of this line. So for that purpose, what we require? So to draw that, we require a compass. So take a compass and place your needle on A. That means you are making A as center. Now what you will do, the line segment, on the line segment take more than half. Okay, more than half with any measurement. Okay, so more than half you fix on your compass needle. Now draw an arc on both sides, this side one and this side one. Now without changing the measurement, so keep your compass needle on B. That means you are making B as a center. Okay. So by taking B as center, cut these two arcs. Okay, cut these two arcs. So once I have cut like this. Now without changing measurement, cut this arc also like this. Now what we will do is, we will join these 2 points. We got 2 points, right? Let it be P and this point let it be Q. Now join these 2 points. So wherever this PQ line intersects AB, mark that point as M. So PQ is the required angle bisector. Okay. So this is the way of drawing. So what we did, just recall. So in steps of construction we discuss again. So let us see the steps of construction. First, what is that? Draw the line segment AB. AB line segment we have constructed. Later, taking A as center and with radius more than half of AB, what you have done? Draw an arc on either side of the line segment. That means upside ones, downside one. Now again, taking B as center with the same radius, draw arcs that they intersect the previous drawn arcs. So from B center we have intersected these two arcs. Now make these point of intersections as a P and Q. So P and Q I have made. Now join P and Q. So let PQ intersect AB at some point O. We have taken M. So let it be M here. So at M, thus the line PMQ is the perpendicular bisector at a point M. So like this we need to write the steps of construction. Okay children. Now let us prove that this is the perpendicular bisector. Okay. So let us prove it. So to prove this, what I will do is, I will join AP, I will join this BP and I will join this QB and I will join this AQ. Okay. I have joined all like this. Now let us see whether it is, we have to show that here the angle is 90 degrees. Now see, what I will do is, I will take these two triangles. What are those? AMP and BMP. See here, I will consider triangle APQ, comma, triangle BPQ I will consider. APQ and BPQ triangles I am considering. So in these two triangles, see, AP is equal to AQ because arcs you have drawn with the same measurements. So AP is equal to BP, next AQ is equal to BQ, and PQ is a common side for both. Right now, PQ is equal to PQ, that is common. So by which rule? SSS rule, triangle APQ is congruent to triangle BPQ. If two triangles are congruent, then their corresponding sides and angles are equal. Already corresponding sides are equal. Now let us take corresponding angles. So corresponding angles means these two triangles. See, these two angles are equal. So that is what I am going to write. So angle APQ is equal to angle BPQ by CPCT. Right? This is equation number 1. Now what I will do, here I have to show 90 degrees, so that I will consider these two triangles and let us see the congruency. Okay? These two triangles I will take. So what are the names of those two triangles? Consider triangle APM. Okay, APM triangle, BPM triangle I am taking. So consider triangle APM and triangle BPM. So in APM and BPM triangle, see, AP is equal to BP and PM is a common side. So AP is equal to BP and PM is equal to PM common. So that is common side. Now see, these two angles are equal, just now we proved. So angle APM is equal to angle BPM. Okay, that is what we have proved previously. APQ is nothing but APM only, right? So by SAS rule, these two triangles are congruent. So by SAS rule, two triangles are congruent. Triangle APM is congruent to triangle BPM. Again, if you two triangles are congruent, then their corresponding angles are equal. Hence, these two angles are equal. What are those? Angle PMA is equal to angle PMB. So angle PMA is equal to angle PMB is equal to, let it be, X. Okay. How you wrote these two are equal? CPCT. Now see, angle PMA and angle PMB both are lying on a same line, right? So angle PMA and angle PMB are lying on the line segment AB. Therefore, angle AMP plus angle BMP is equal to 180 degrees because linear pair. So AMP and BMP we have assumed as X plus X, that is equal to 180. So 2X is equal to 180 and X is equal to 180 upon 2. So that is equal to 90 degrees. So here this angle 90, this angle also 90. Hence PQ is a angle bisector. Okay, the angle 90 we have shown. So by CPCT, one more thing we can write, that is AM is equal to BM. By CPCT, AM is equal to BM. See, M is the midpoint and through that midpoint you have drawn a perpendicular, hence PMQ is the perpendicular bisector. So this is the proof you need to write in exam if you ask justification. Okay. Next, so construct the bisector of given angle. So we know that already. So let us prove it again. Now let us take an angle and let us name it as ABC. Now we need to construct the angle bisector for this angle. Okay. To do that, what we will do is, let us take the compass, take B as the center, vertex of the angle as the center. Now construct an arc. Okay, here. So wherever it meets, wherever it intersects, these two rays, okay, arms of the angle, let us assume those points as D and E. Now without changing this measurement, place your compass needle on E, draw an arc with the same measurement. Okay, let us draw an arc without changing measurement. Take E as a center and draw an arc like this. Now again without changing the measurement, place your compass needle on D. Now draw another arc which intersects the previous arc. Okay, let us name this point as a F. Now construct a ray from vertex B through point F. So this ray will bisect the angle whatever we have taken. This is the way we have to draw. Okay, once again come again. See here, first what we did. So let us discuss this in steps of construction once. Okay. Now steps of construction, let us see, then we will understand more better. See, step 1, draw the given angle ABC. So we have constructed an angle ABC. Later, taking B as a center and with any radius we will take, draw an arc to intersect the rays BA and BC at D and E respectively. So that is what we have constructed. Later, taking E and D as a center, draw two arcs with equal radii, so to intersect each other. So with equal radii, what we have done, from D and E we have drawn two more arcs. So wherever they intersect, that point will be F. Now draw the ray BF. So that is the required bisector of angle ABC. Okay, that is the required angle bisector. Now let us justify this. What do you mean by justification? This angle is equal to this angle. That is what we have to prove. Angle bisector means it will bisect this angle into two equal halves. So we have to show that this angle is equal to this angle. These two angles are equal. That is what we have to show. To show this, what I will do, I will join DF and I will join EF. Now see, BD is equal to DE. We know that these two are equal, and DF is equal to EF. This also we know that. Okay. Now from that figure we have two triangles, right? This BDF triangle and BEF triangle. I will take those two triangles and I will prove both of them are congruent. Okay. So consider which two triangles? BDF triangle and triangle BEF. So these two triangles I have considered. In these two, BD is equal to BE. Next, DF is equal to EF. And see, BF is common side, right? BF is equal to BF, that is equal to common. So common side. Therefore, which rule? All three sides are equal. So by SSS rule, triangle BDF is congruent to triangle BEF. If two triangles are congruent, by CPCT we will write by corresponding parts of congruent triangles. From that we will write angle DBF is equal to angle EBF. Okay. Hence BF ray is an angle bisector. This is the justification for angle bisector. Okay. Next one, see, to construct an angle of 60 degrees at the initial position of a given ray. So, let us take example 3. Draw a ray AB with initial point A. So, and construct a ray AC such that angle BAC is equal to 60 degrees. Okay, let us do this. Let us take a ray AB. Here A is initial point. Okay, here we need to construct angle 60 degrees. Now take compass. Where we have to construct 60 degrees? At A. So keep your compass needle on A. By taking this as center, construct an arc like this. So wherever it intersecting this ray AB, that is the point D. Now place your compass needle at D. Now intersect this ray with the same radius. Okay, without changing any radius, we need to cut this. Okay. Now draw another ray. So let us, this point will be some E. This point is E. Now join AE ray AE. So if you measure with a protractor, you will get angle here 60 degrees. This is the way of constructing 60 degrees. How we have constructed, children? So let us discuss with the steps of construction. Now see the steps of construction. First step, draw the given ray AB and taking A as a center and some radius, draw an arc which intersects AB, say at point D. So that is what we have did. AB ray we have drawn. So by taking A as center with any radius, we have drawn an arc which intersecting the ray AB at D. Next, taking D as center and with the same radius. Taking D as center without changing the radius, we are cutting this arc again. Okay, we are intersecting this arc. So taken before, draw an intersecting previously drawn arc, say at a point E. Now draw a ray AC passing through E, then angle BAC is equal to 60 degrees. Okay. So this is the ray AC which is passing through E. So this is the required angle 60 degrees. Okay. Now let us see justification whether this angle is 60 degrees or not. Okay. To justify this, what I will do is I will join E and DE. Okay. Now observe the triangle ADE. Consider triangle ADE. So I am taking triangle ADE. So which type of triangle is this? That is what we have to see. So AD is equal to AE because both of them are with the same arc, right? Now see, AD is equal to DE because with the same radius again we have drawn arc here. So DE also equal. Therefore AD is equal to AE is equal to DE. So all three sides are equal. Therefore triangle ADE is an equilateral triangle. So in equilateral triangle all angles are 60 degrees, we know that. Therefore angle EAD is equal to 60. So EAD is nothing but CAB. So angle CAB is equal to 60 degrees. So like this we will justify our drawing.